Hello and welcome. I'm John Ball, cognitive scientist and entrepreneur specializing in brains and computers. In other words, I'm an AI expert using the science of cognition to drive my work. My distant ancestor, the scientist Michael Faraday, is famous for saying that nothing is too wonderful to be true if it be consistent with the laws of nature. In this new series, I will explain how we bring the laws of nature into our AI work to break through to the amazing capabilities we've all been dreaming of. How long will this take? I believe in as little as 5 years to see global adoption. I'm not proposing to create robots that emulate all aspects of humans, but to change how we interact with our devices using our choice of language to change how quickly and easily we can get things done. This promises to be an amazing journey. What will it take to move from robots that are easily confused to ones that are like us? That's the question. In upcoming episodes, I will look at the work of others, such as the neural network guru, Turing Award winner and Nobel Prize winner in physics, Geoffrey Hinton. And there are many others whose work I will contrast with the cognitive sciences. This leads me to today's focus. How do we solve AI by using the laws of nature? First of all, there's two kinds of science to consider: formal science and natural science. Formal science creates rules and then applies them. An example is Noam Chomsky's linguistics that has dominated since the 1950s. You cannot falsify a formal model because it isn't compared to the real world, only to its model. Today in the AI field, we keep hearing how AI will solve problems this year or next year or in a couple of years. But just improving against benchmarks isn't progress in a field of infinite scale. Natural science is empirical. Galileo's study of astronomy is an example where he observed the skies and made theories to explain the motion of planetary moons. That was a breakthrough in astronomy, perhaps heralding in the modern scientific method. Formal sciences include mathematics, statistics, and computer science. To read more on formal and natural science, look it up on Wikipedia under, quote, branches of science, unquote. Consider the formal science used in today's generative AI, starting with machine learning. Machine learning is a two-step process, starting with 1, a training step to collect the patterns from data to use later, and then 2, generalizing when given previously unseen data. Now, is this how we learn? No, it isn't a human-like approach. Can machine learning do everything that humans do in theory? No, because we learn on the fly all the time, even as 3-year-olds. There's a book called The Island of Bum Bum Baloo. Do you know what Bum Bum Baloo is? Yes, it's an island, probably fictitious. But someone tomorrow could write another book we've never heard of, and yet we learn its name on the fly. This happens all the time. In natural science, we have falsified the model used by generative AI, and yet its supporters are claiming strong AI or AGI will come from it, maybe this year, or maybe in 10 years. In my view, probably never. Not with that approach, because the model is alien to brain function, and the problems are just too big to solve that way. The point is that generative AI fails to emulate humans even on this fundamental requirement. Machine learning doesn't learn on the fly by definition. What will I cover in this series? I'll look at the models for AI and where they fail at human emulation on the basis of empirical comparison. Cognitive science is natural science because it's made of other natural sciences: linguistics, neuroscience, philosophy, psychology, and anthropology. It also includes the formal sciences of AI or computer science to replicate human capabilities inside this model. My biggest conclusion in recent years is that the computational model is no good for brain function. It brings in too much baggage, and that baggage holds up solutions for AI. I developed pattern theory to model brains. It's theoretical neuroscience as a result, and is therefore a hypothesis that underlies a natural science. It works well for emulating human language, for example, a topic considered impossible to emulate in real time by many due to famous research work at MIT in the 1987 book, Computational Complexity in Natural Language. But of course, its conclusion is wrong, since we humans use language all the time. In this series, I will also refer to the linguistic model known as Role and Reference Grammar, or just RRG for short. Its primary developer and I have validated its limited use across a number of languages in the last 10 years, enabling me to make the claim that our collaboration enables the next generation of AI that uses human language. What's the goal of this new series? To show how the revolutionary approaches to brain science from pattern theory and to linguistics from RRG are central to the next generation of AI, of artificial intelligence. And there's a lot of examples in today's AI and cognitive science to provide food for thought. Next time, I will walk through how human languages are recognized in real time with my system without the use of parts of speech to find phrases, and in a way that is at odds with the traditional parsing methods used since the 1950s. The approach is supported by observation with empirical science to build a dictionary that generalizes and to store meaning that aligns with the world's diverse languages. This puts us on a path towards humans working with machines in their own language within 5 years, regardless of their language. Transacting with others easily and seamlessly in spoken or written language is one of the goals of AGI. This approach shows how to enable that. Imagine buying things by asking for them and doing banking transactions as easily as with a human teller. Thank you for joining me today, and I look forward to hearing from you as the series progresses. And if you can, remember to press the like button if there is one. That's all from me today. Goodbye for now.